And now we are on to our third and final help video over the density of pennies lab. This is like video number 135 over density lab 1-9. When we left off, we were last talking about why the experimenter did multiple groups of pennies. He did one group of pennies, then he added another group of pennies on the balance, added a third group of the same type of pennies on the balance, then a fourth group of the same type of pennies, and then he had 5 groups of pennies on the balance. And we noticed that the density did not change as he added more and more groups. You might say, oh my gosh, the density did change. It was 7.1 here. Well, we saw that if this number was a little measured incorrectly, maybe it was 6.0 milliliters, trying to look at those graduated cylinders which were difficult to read. If this was only 6 milliliters and we read it as a change of 6.5, that would change that number back to 7.7. So regardless of how many groups of pennies were on the balance, the density stayed right around that 7.7 mark. And that is because the density of a substance is an intensive property. It doesn't matter how much you're looking at, and that is because as you add more of the substance on there, the mass will change, but so will the volume. So when we're looking at just that group 1 pennies, the mass was right around 15, the volume was right around 2, density 7.7. When all 5 groups were on the balance, the mass went up to 77, and the volume went up to 10. So the mass increased 5 times. The mass increased 5 times. But the volume went from 2 to 10. The volume also increased 10 times. So the mass went up 5 times, but the volume also went up 5 times. The mass increased by 5 times, so that would be 5 times more on top. The volume increased by 5 times, that's 5 times more on the bottom. Factor out the 5 and 5, the density doesn't change at all. The density changes by a factor of 1, which is not a change at all. Were there errors in the lab? Oh yeah, we already talked about errors. The mass, well, the balance is not exact, so there is some error in the balance. The balance in these particular balances went out to the 1,000th place. Those are very nice balances. But it's still estimating. It's not an exact mass. The balance estimates for you, so there's little or no user error when using a balance. But the volume had lots of user error introduced. Reading those volumes on a graduated cylinder was very, very difficult. So that did introduce error. And we saw how a small error in the volume could result in different calculations or results for the densities. Were the pennies actually gold? Were those gold pennies actually gold, or were they gold colored? Let's go back and take a look. What was the density of those gold pennies? The mass was 30.72 and the volume was 4. We got that from the chart right up here. The mass was 37.2. The volume or displacement change was 4. 30.72 divided by 4, 7.7. That's a density very close to the pre-1982 pennies. The pre-1982 pennies were all right around 7.7, except for the one that had a volume volume reading error. The density of these gold-colored pennies was the same as the density of the pre-1982 pennies. That's because when you're trying to make the pennies go from that copper color to silver and gold, it works best with the pre-1982 pennies. There's a chemical change that's done in that first step, and the chemical change works better when you have a high incidence of copper in the pennies. I know these weren't gold. How? Well, the density of those gold-colored pennies was right around 7.7. The actual density of gold is 19.3. 7.7 is nowhere close to 19.3. You could mess up the volume readings all day long as you're dropping those pennies in the graduated cylinder, and it's not going to get the 7.7 density up to 19.3. Those pennies are no way could they be gold. Now, if the density of those pennies was somewhere around 19, maybe up to 19.8, then we would really wonder, are they gold? Because 19 in this lab would have been very close to 19.3, considering volume difficulty readings. 19.8, very close to 19.3, considering you had difficulty or would have difficulty reading the volume differences. So we can conclude that there is no way that those pennies had a remote chance of being actual gold. There is no way. Finally, the last question. Why does it make sense that the density of brass is somewhere around 8.4? When we go back up to the table of values that we had in our background for this lab, the table of known densities, brass is around 8.4. Why does that make sense? Brass has both copper and zinc metal mixed together, melted and mixed together. That's what alloys are, metals that have been melted and mixed together. Brass is copper and zinc. Its density is right around 8.4. Why does that make sense? Because it has copper, whose density is 8.9, and zinc, whose density is 7.1. If it has copper and zinc in it, the value for brass density should be between those two. 8.4 is in fact between those. If you had a lot more copper than zinc, the value of the density would be closer to 8.9. If you have more zinc than copper, the value would be closer to 7.1. So a mixture, an alloy is a mixture. The density of mixtures can change freely depending on how much of each substance is in there. If you have more of one than the other, the density value will change. And the big thing we want to talk about is the difference between mixtures and compounds. Mixtures and compounds. The density of a mixture is dependent on the percentages of the stuff in the mixture. The density of a compound would not change because a compound is only allowed to be made one way. You can't have different amounts of substances in there. So I'm going back to right here. The post-1983 pennies are 97.6% zinc and 2.4% copper. So they're mostly zinc and a little bit of copper. Their density should be a lot lower. It should be closer to zinc. The pre-1982 pennies, their density was higher because there's 95% copper and 5% zinc. So when you change the percentages of the substances in a mixture, the density changes. That's not the same case with compounds. Compounds are not allowed to vary in the amount of elements making them up. You can't just arbitrarily decide how much substances you're going to put together to make a compound. Water is a compound. A compound is two or more different elements that have joined together chemically. Water always has two hydrogens in the compound for every one oxygen. So water is always 2 parts hydrogen, 1 part oxygen. We see that when we're making an alloy with a mixture, we can change the percents of things in there. When you make a compound, you are not allowed to change the percentages of things in there. Water is always H2O, which means it always must have the same percent of hydrogen and the same percent of oxygen. So as we mentioned, water is always H2O, there are 2 parts of hydrogen for every 1 part of oxygen in water. You can't change the formula of water. It is always H2O. So what does that mean? Hydrogen has a mass of 101. 1.01. Oxygen's mass is 16.00. So there's 2 hydrogens in there. 2 times 101 is 202. Oxygen has a mass of 16, but it's 1 part oxygen. So it's 1 times 16 is 16. So water has 2 hydrogens totaling 202, 1 oxygen at 16. 2.02 and 16 is 18.02. So how much of water is hydrogen? Well, there's 2.02 part hydrogen. Water's total is 1802. If you take 202 divided by 1802, it's around 11%. Water is 1 part oxygen. Oxygen is 16. Water's total is 1802. 16 divided by 1802 is 89% oxygen. Water is a compound. It is always a compound made up of 11% hydrogen and 89% oxygen. The percentages of elements in a compound cannot change because a compound can only be made one way. You can't mix different amounts and have water. However, we can see with the penny, which is an alloy very often of different metals, you can adjust those percentages in a mixture however you wish. So we could have 50% zinc, 50% copper. The total there would be copper's density, which was, as we mentioned, around 8.9. Zinc's density, which is 7.1. You could take those 2 numbers, add them together, divide by 2, and that would give you, if it was 50% one, 50% the other, the total density would be the average densities of these substances making them up. So we've, in a weird way from this lab, we learned the difference between a compound and a mixture. A mixture, you can change the percentages of each thing in there. You can change the density of it. For a compound, however, you can't change it because it only has one formula to make it. So there is always the same percentages of elements in there. Hopefully, you were able to pick up some of these very interesting points that this density lab brought us to. If you have any questions at all on this lab, don't hesitate to ask during one of the Zoom meetings or schedule an appointment during office hours, and we can talk all you like about the density lab. Thank you very much.